Okay, this is the solutions to the pink sheet, I'm calling it. So this was another example. This is an old notes packet. Before we had StatsMedic, we did just guided notes out of our own textbook. So that's kind of why things might sound a little bit different. I mean, it all comes out at the end the same, but I just want you to have different examples, terminology that you might not be as used to. So I'm going to shake it up a little bit. Anyhow, so this was the last of the 4 examples, and so I probably should have started with an earlier one, but that's okay. So in class, we got this far. We talked about at birth, the baby's average 7.8, and the standard deviation is 2.1. So that is the population parameters. A random sample of 34 babies born to these mothers living near a large factory is only 7.2 pounds. Is that statistically significant? So we're going to see. So we need our assumptions and conditions to be met. So again, first semester, a lot of these were pretty exact. You know, the number of Skittles, I pull out a handful, I'm not putting them back, I'm eating them, is the 10% condition met? So in real life, you're kind of using a lot of words like assumptions or it's stated. So for the random, the problem does state that the sample is random. They took a random sample of 34 babies. For the independence, and I'm sorry, you don't always see my handwriting, it is reasonable to assume that birth weights in this region are independent of one another. So I'll get better at that at writing as the semester goes on, and you have to too, because you write your AP test. So you have to get really good at that. Sometimes on your tests, I can't read what you're saying, but I can kind of assume, but a test reader may not be that generous. Okay, the 10% condition this is one way to see it. This is how your textbook usually states it. Last semester, you might have used 1/10. Is 1/10 of the population greater than the sample size? Or is the sample size less than 1/10 of the population? Some of you use 0.10. Okay, but your textbook uses this. Again, any one of those ways. But we can assume that 340, which is, 1/10 of the population, is that bigger than the number of babies born in that region. So this is where it gets a little fuzzy. We don't know the population of this region. Most regions are in the thousands, right? If not the millions. So, but even Orland, is 75,000 or 150,000 or whatever. So that'll fit the condition. Now, this is where you will have your formula sheet, okay? So we have the mean of X bar is 7.8, okay? And the standard deviation of a sample, you have to take the square root. So this is the piece that we may not be quite as far along. We'll have a lot more examples as we go. But you have to take the square root of the sample size to get the standard deviation of this sample. Okay, thanks. All right, so that is what we're going to use, 7.8 and 0.36. So you take the standard deviation of the population divided by the square root of the sample size. And because we're working with a smaller set, we have that smaller standard deviation. I'll probably kind of keep bringing you back to the sampling distribution of the AP exam scores, which was the StatsMedic, or Beyonce's lyrics. Okay, so here is everything, though, that you need to know. So this is where, if you're like, oh, I forgot all this. So when kids ask me if I should throw things away from first semester, maybe not, because you have a lot of stuff that we've done that you do have to use again. All right, so if we start with 7.8 and then add our 2.1 not the 2.1, okay? So this is where we're gonna add or subtract the 0.36, okay? To kind of get to our, so 7.8 plus 0.36 is 8.16. That's one standard deviation above. I'm literally just adding 0.36. 8.52, you can't see with the glare, the lights are on, and so on. So then we have 8.88. When I subtract 7.44, 7.08, 6.72. So I'm kind of just kicking it really old school with the empirical rule, just so you can kind of see that 68, 95, 99.7. And remember, these are not, try to write better, individual baby weights. Okay, they are averages of samples. Of 34. Okay, so that's normal. You always want to identify, and then don't forget this is 0.36, not the 2.1. Okay. Okay, so you're basically, this is the sampling distribution. So this is what we just spent the whole first week on. A sampling distribution is this particular sample of 34 was 7.2. Is that exceptional? Is that statistically significant? Okay. Okay, so that's what we're looking for. If the probability that mean is less than 7.2. Okay, so if you are lining it up under there in that same, like this is still 7.8, we knew that 7.2 landed in here somewhere. Okay, so it was between the first, there's the second, between the second and third. So it's right in here if you want an accurate picture. Okay, you can rewrite this if you want. Okay, so that's what you're looking for. So now hopefully you're kind of like, oh yeah, I'm going to use normal CDF. 0, okay, 7.2, 7.8, and 2.1 divided by the square root of 34. Now I'm going to tell you a couple things. If you wrote that down on the AP exam, that would be sufficient. You cannot say like on calculator. You have to show your calculator. And now an added bonus is you have to show your show what each point is. Okay. So let me see. I'll get this away from the glare. So I just went to second vars. Okay, your distributions menu. Now you actually know what that is. Yay! Okay, so we are going to do normal CDF. So we already proved it's normal with the conditions. So yay. So option 2, the lower. Now I'm saying 0 because I'm using the real data. So there's no baby that is 0. But if you want to put negative infinity, like somehow. But this is your lower bound. This is your upper bound. Okay, then you've got your mean and your standard deviation. So I'm using actual data. That's why I didn't find the z-score. So we had a lot of chats first semester. If you want to do the z-score, then you would use 0, 1. Okay, hopefully you're having some aha moments right now. I mean, that's plenty. Okay, so what do we want to say now? Okay, according to the normal model, only about, okay, 4.8%, I'm just gonna round here, of the samples, not of the babies. So context, right? Only about 4.8% of the samples of 34 babies, don't say babies, are expected to have a mean birth weight below 7.2 pounds. Okay. So the sample suggests, right? Kind of the baby's born in the vicinity of this neighborhood, of this factory rather, could have unusually low birth weights. I gotta start writing smaller so this all fits. There we go. All right, sometimes I just like to white out like page numbers and things like that. They start to get in there. All right, guys, so this is your takeaway. It's a little bit of everything that we've been at, but we're gonna keep formalizing this. Okay, we're gonna have a significance test. We're gonna have a null hypothesis that says, you know, babies born in this vicinity are under the national birth weight. And, you know, then again, if I'm a lawyer trying to have a court case, this is what I am seeing. So then I take another sample of 34. Well, gee, that fell under the 5% as well. I have another sample of 34. Is that gonna fall? Then you start to have a case. All right, so that is, again, we're getting to the holy grail of the p-value and significance testing. So this is the end of the pink page. Little bit ambitious for a Friday afternoon, I apologize. So I would like you to do the blue example then for homework. I'll put this on Canvas and then do kind of the exact same thing here. Now, not everything has the same, you know, outcome. So don't just assume, you know, that it's always going to be the same or it's always going to be significant. Sometimes it's not. Alrighty. So that is all I got for you. Thanks for watching and learning.